Some 2000 years ago, Roman civilization was at its peak of prosperity. Romans had God for every imaginable thing. They believed that their gods gave them a sense of pride and insight into their destiny. Neptune was the god of sea and had a reputation for being bad-tempered. His anger and rage were related to the shaking of the earth. Saturn was the god of agriculture. Whenever the crops went bad, Saturn was enraged and demanded prayers and sacrifices. And Jupiter was the king of gods. He ruled the skies and shot thunderbolts to protect the cities. How does one know that it was Neptune responsible for earthquakes and Jupiter responsible for lightning strikes? How does one know that there is a god responsible for raining or not? What is the truth? The first step forward in understanding the truth was taken even before the Romans flourished. In ancient Greek civilization lived scholars like Thales, Pythagoras, Anaximander, and Aristotle. They explained the raining and the lightning strikes without invoking an angry god. They explained these mysteries as interconnections of several natural processes. Like an eclipse is caused by moon's intervention between earth and sun, and not by any monster or angry god. Thus, they laid the first stone in finding the truth, to look at the world as it is and make logical deductions. They even established a form of logic system and preached how to make logical arguments based on a given premises. However, something was lacking in their pursuit. By just observing and making deductions, they ended up making speculations. Like Democritus speculated about the existence of atoms, and Aristotle thought that a man has more teeth than a woman. Why should one believe in Democritus' speculation? And how to resolve a conflict when two scholars reach different conclusions through deduction? For that, the world had to wait for another 1300 years. When the Europe was sleeping in the Dark Ages, there was a golden age for science in the Middle East. It was here the method of science was first written down. Seekers of truth must not put trust in the writings of ancients. Question and critically examine these writings from all sides. Seekers must also suspect their ideas as they perform the investigation to avoid any prejudice and careless thinking, and base judgment only on arguments and experiments and not on the sayings of any person. These words form the basic structure of modern scientific method. These writings fueled the Renaissance in Europe hundreds of years later. Scientific method is a process of acquiring knowledge based on observations, arguments, and experimentation. But it all begins with a question, like, is the moon made of cheese or rocks? Then take a step to critically examine the question against the current knowledge and observations and develop a hypothesis to explain those observations. Looking to the moon at night, one sees craters caused by asteroid impacts, which implies moon doesn't have any atmosphere that can block most of sun's radiant heat. Therefore, one could expect temperature around 200 to 300 degrees Celsius. If cheese is heated at about 50 degrees Celsius, it melts. Temperature of moon is high enough to melt cheese. Now, since we don't see the surface of moon melting, so probably the moon isn't made of cheese. If lot many people still believing that the moon is made of cheese and are outraging you, don't give up. Tell them to send an expedition to the moon's surface and the truth will be revealed. That's experimentation, which settles all arguments. And hooray! You have contributed to the understanding of the universe. When you collect a lot of such interconnected hypotheses and that supports experimental evidence and can make testable predictions, then It is called a theory, like Darwin's theory of evolution by natural selection, or your theory that celestial bodies cannot be made of cheese. In physics, one has to understand the distinction between a theory and a law. A law is like an observed rule that describes some natural phenomena but does not give any justification for itself. Like Newton's law of gravitation, it can describe the motion of planets around the sun but does not answer why it does that. A theory, on the other hand, tries to provide a complete description of natural phenomena, like Einstein's theory of general relativity, which describes gravity as a curvature of space-time. The seekers of truth always come up with a theory that gives a better understanding of nature. However, there is an essential criteria against which theories are to be tested. It is called the falsification criteria. A scientific theory is meaningful because of its falsifiability rather than its verifiability. Statements like energy is always conserved can never be completely verified, since it would take an infinite attempts to do so, but can be disproved by one single observation. Also, verification of almost anything can be accompanied by appropriate selection of evidence. When a theory supports a particular experiment, we say that the theory is not wrong and continue to hunt for more experimental tests. A theory thus can never be completely correct. This birth and death of theories constitute our understanding of the universe, and that's what makes science work. Science is never fixed. It never concludes. It always tries to feed curiosity of what it desires. In the end, we are just some creatures trapped in this incomprehensible world, trying to understand its rules by observing nature's gameplay. So continue doing it and never stop questioning.